Hello and good evening, everyone, and welcome back to Cloud Native Wednesdays. My name is Rav, and I'm the Program Manager at Reactor London. We're going to continue with the 5th episode of the Cloud Native track in the Championing Azure Collection series. This series provides an introductory overview of Microsoft's Cloud Native and is perfect for those early in their developer career. Today, you'll learn more about cloud-native solutions on the Azure platform and how you can leverage these technologies in a responsible way to enhance your applications. Before we begin, please take a moment to read our Microsoft's Code of Conduct. We're all here to learn, so please be respectful of other people's views, understanding of differences, and be kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. Our speaker today has prepared some learning resources for you to be able to get the maximum out of the session today. So please go ahead and take a screenshot of this slide and check them out. I will also be putting them into the chat in a minute. And now let me introduce you to our speaker Jakob today. Jakob has over 20 years of experience with professional software development and currently works as a programming architect at Active Solution, specializing in DevOps and cloud architecture. Jakob is also a Microsoft Azure MVP, and he regularly speaks at conferences such as NDC, UpdateConf, Cloud Views, DevSum, and Tech Days. He is also the co-organizer of the Swedish Microsoft ALM and DevOps meetup. In this session, we will look at a new option in Azure for running cloud-native applications called Azure Container Apps. The session will run for approximately 40 minutes with some time for Q&A in the end, but I do encourage you ask your questions as the session goes. Just drop them in the chat. I think I've said enough, Jakob. I'll hand over to you now, and I'll be in the background if you need me. Yes.
Okay, thank you. So let me share my screen. Okay, fantastic. So thank you for welcoming me to the Cloud Native series. This again is the 5th session, and a couple of colleagues of mine have performing the previous ones, and if you didn't catch them then, they're recorded, so you can watch them at the Reactor YouTube channel. So let me just start by introducing myself. Again, my name is Jakob. I'm an Azure MVP working at a company here in Stockholm, Sweden called Active Solution. I've been an MVP for many years. I used to specialize in the DevOps area, written a few books on the topic. So typically, I focus on cloud architecture, DevOps processes, tooling, and so on. And please contact me, anytime after the session on Twitter or through my blog if you want to continue discussing any of these topics that I will talk about today. And again, if you're a software developer living in Sweden, I'd welcome you to check out Active Solution. We're always looking for good software developers all over Sweden for doing things such as cloud native applications, for example, running on Azure. So again, this series is around cloud native, and we already had a session kind of explaining what cloud native is, so I won't delve into the topic in much detail in this session. But when you're talking about cloud native, the topics of microservices and containers is very, very common. It's not strictly a requirement. Cloud native is more like a way of packaging your application code and dependencies and how you run them. But in real life, using container technology is very, very common. And also microservices type of architecture is also common. And there's a reason for why microservices and containers is such a good fit. So if you're aware of a microservice architecture, like the opposite of that one is what you usually call like a monolithic application, where you have your application and your database is pretty much packed up into a single process, and you build and you deploy everything at the same time. Quite common. This would be also the same underlying platform technology such as .NET or Java, and maybe you have one single database running SQL, for example. While on the other hand, if you move in towards a microservices architecture, you tend to split this up into multiple services, which you can now build, test, and deploy in isolation, independently from each other, and also use different types of technologies. So now you don't have a single database, or you don't have the same development platform everywhere. So each team can pretty much select the best the best tech for that particular service. But that can result in another kind of problem, because now you have multiple ways that you need to do to build your application, how you should package it, and how you should deploy them. And this is really where containers shine, because if you package your application into a container, it doesn't really matter if it's a .NET application or Java or anything else. A container image is really a standard. Once you have packaged it, you now have very many options of how you can actually deploy them, and the configuration works the same way. So microservices and containers really has gone hand in hand. And we'll be looking at talking about different options of running containers in Azure, and I will be focusing on a new one. But before we talk about the Container Apps service in Azure, let's just take a step back and talk about what do we need if we want to run a multi-container application. So this means like a system that consists of one or more containerized services. So there's a few things that we will be needing. So the first one is like service discovery and service-to-service communication. So if we're running multiple services, we need a way to discover and talk to the other services. So there's not really a point of doing microservice architectures if the services doesn't talk to each other. So you need a way to make that happen and make that easy and fault-proof. Another thing we want is to be able to deploy new versions of our software without downtime. So this is typically in the containerized world. This is done by not touching the existing container. Instead, we deploy a new version of the container in parallel, and then we can redirect the traffic to the new container. And then when that is done, we can remove the old container. But still, we need something to do that for us. It's not that some kind of service needs to handle that. We also want to be able to auto-scale apps. So one of the reasons we're doing microservices is to actually be able to scale each service independently of each other. So we need a way to auto-scale based on different things, such as metrics like CPU, memory, but also events. So things like messages on a service bus or message queue, for example. That is something that should cause our applications to scale. Monitoring, distributed tracing, these are things that it's actually kind of becomes a little bit harder when you break your application apart in multiple services. So you need something that can extract metrics and logs from your services and aggregate them and visualize them. So you can be able to understand the usage of your application, but also to troubleshoot the application in this distributed sense. And again, we don't really want to care about the infrastructure. Now we're in this cloud world. We basically just want to deploy our application and let, for example, Microsoft Azure care about the underlying infrastructure. And in addition, it would be ideal if we just pay for what we're using here. So I don't want to pre-allocate a lot of infrastructure that I might or might not be using all the time. So ideally, I just want to pay for the resources that I'm actually using. So if I scale up, of course I would pay for that. But when I scale down, I should only pay for the actual usage. So looking at in the Azure ecosystem, there are multiple options for running containers. And so a few of the most popular ones is first up, we have the Azure Container Instance. So this is really, I'd say, the easiest way to run a container in Azure. It's pretty much just doing one single thing. It says run this container, and you just pay for the amount of resources that you're using. So this is perfect for doing like a single thing, like for example, batch jobs, background jobs, like orchestration jobs. It's not really meant for running applications that is up for running a long time, like web application, for example. So it has a very specific purpose, and it's really good at doing that. but it's not really meant for running multi-container applications that is up and running for a long time. Another option, if you're doing web applications, is the Azure App Service, which of course is how you run web applications in Azure. So you can do that both without containers, but also with containers. You can deploy a container image and have it run as an Azure App Service. So if you're just building web application, the Azure App Service is a great fit for that. You can still use container technology and then get the benefits from the Azure App Service. But if you're doing like more of a microservice type of application where you have maybe multiple web applications and also public and private APIs and so on, Azure App Service can be a bit cumbersome to actually implement that. So the next option is like the full beast, so to say, which is when you go into select the Kubernetes as your underlying platform. And in the case of Azure, you have the Azure Kubernetes service, which is the managed service for running Kubernetes in Azure. And this is of course a very powerful platform, and you can do a lot of things with it. So it can do anything around orchestrating your containers. But it does come with quite of a learning curve. There's a lot of new concepts that you need to learn. And even though, in this case, Azure will, kind of run it for you, you still have to kind of deal with your nodes. You still need to understand how you can troubleshoot, Kubernetes deployments, how you set up security, and all those things. So this has been kind of the problem around Kubernetes. It's super popular. A lot of people are attracted to it, but it is quite a learning curve. And the option that we'll be talking about now is really, I'd say, this type of services, we're going to see a lot more of that in the coming years, where basically we're looking at abstracting away a lot of the complexity and details around Kubernetes and build something on top of it. And this is what Microsoft has been doing with the Azure Container Apps. And this service is still in preview. I want you to take note of that. So it's not generally available yet. So you don't have full SLA, and you shouldn't run it in production just yet. But I expect that it won't take too long until we have production support for it. So again, this is it was launched at Ignite last year, and kind of the keywords here is running serverless containers for microservices. So serverless containers. What you mean here is that you don't need to provision anything anymore. You don't need to provision a Kubernetes cluster or an app service. You just say, I want to deploy my application, and I want to have Azure Container Apps to, for example, scale it for me and handle things like logging and so on. So this is about building modern apps based on open source, and I'll explain that in a second. And again, the focus here, the idea is that you can focus on your applications now. You don't need to care about the infrastructure. It's not tied to any particular language or framework. Since you're packaging it into containers, of course you can put anything in there. And again, this is actually built on top of Kubernetes, but still some of the Kubernetes kind of concepts will kind of leak through. But that's actually kind of in a good way, because this means that if you're investing in container apps, and at the end you find that you might need more control, maybe you actually need to go into Kubernetes, this should actually be quite a seamless upgrade, because you can take your existing investments and quite easily move that into a full Kubernetes deployment. So the Azure Container App Service is again, I told you, it's built on top of Kubernetes, but it also embraces a few of the open source projects that exist in the Kubernetes ecosystem, such as Kada and Dapper and Envoy, and I will come back to these things. So instead of actually building everything by themselves, they actually are embracing these open source projects and leverage them in the service. So you don't need to care about how you actually install and configure it. You can just use those services and platforms to make it easier, for you to build microservices and to be able to scale them, for example, and do things like traffic routing. So a few common scenarios. This is just from the Azure Container Apps documentation site. So what could you build potentially with container apps? And so of course some popular or common examples would be to build one or more public API endpoints, which will then accept HTTP traffic, and you can scale them on the number of concurrent HTTP requests. You can do background processing, for example, for doing data transformation in the background. And again, in this case, you could potentially scale it on the level of CPU or memory load. Event-driven processing, of course, is very, very common. For example, reading messages of a queue and process them as they arrive. And in this case, you would want to scale them, by the number of messages in that queue. And again, another example would be here like a full microservice architecture, where you can deploy and manage your microservices, and with the option now to integrate that with Dapper that I will talk about later. And again, now you can scale each microservice individually on different types of triggers and different sizes here, which is really what you want in a microservice architecture. So getting started here is super easy, and this is really one of the key points. You don't need to learn a lot to get started with a container app in Azure. This is basically the only thing you need to do when you get started. You create something called an environment first, and then you create your container application. And I will show you this later on. And I will also explain the concept of an environment. But the key point here is that you don't need to create a cluster. You don't need to provisioning anything like beforehand. You can just deploy your application into that environment. And of course, then you can add multiple applications as well. So here I'm using the Azure CLI. You can also use ARM template or Bicep if you're familiar with that. So the same thing would look kind of like this. So you have multiple options, and if you do this from a deployment pipeline, you could select either of these options. So actually, let me get started by just showing you how easy it is to create one of these applications. And let me hop over to, actually, let's take this one and go into the Azure portal. Let me zoom in a little bit. So I already I have a resource group here called the Container App Demo, and I already had an existing environment here. And I will explain that concept in a minute. So what I want to do, just to show you now, is I want to deploy a container application. So let me just create a resource. I search for the container app, and you can see now it's marked with preview. So just be aware of that for now. So to create the container application, I select the resource group, and I will give it a name. So I just call it the Container App Demo. And then I'm going to select this environment in which it will run, which I already created. So I'll just pick the Container App Demo. It didn't pick my name there, so let's do that. And let's go to the app settings. So in this case, I will now select a container. So I need something to deploy here. So I could select the quick start image here, the sample, or I could actually deploy one on my own. So let's just give it a name again, demo, and I can also just now point to an existing image. So I will actually use the image that is referred to on the Azure documentation site, which is just called Container Apps Hello World. So I'm just going to paste that in here. So it's just Azure Docs/Container Apps-Hello World. And you can see I can also specify things like CPU and memory. So you can see that I have a few different sizes here. And also I can select what's called the Ingress. And this is about directing traffic to my container app. And for some applications, I won't be needing this. If I do, for example, background processing, I don't need to have HTTP traffic coming into it. If I'm building a web application or a web API, I do want traffic, to be able to reach it from the outside. So in this case, this is a web application, so I will enable Ingress. And now I can also select, should this be just reachable from inside my environment? Maybe this is an internal API. In this case, I want to accept traffic from anywhere, so from the public internet. And I'm just going to specify port 80 here, which is the web port internally in my container. So let me create this one. And this usually takes just a few seconds to create. So now it's going to deploy this container app with pointing to the image, and we'll see what we get when it's done. So it should just be a few more seconds before it's done. And so even though this is in preview, it's available for anyone, so you don't need to do anything special to try it on. It's available in your Azure subscriptions. So feel free to try it out. And also the links that you get for the learning modules is basically pointing to the existing documentation. So since this is a preview service, there's not a lot of learning modules and so on. So basically just gave you the links to the official documentation and the GitHub repo and so on. But there's a lot of information there, and you can also follow along on the GitHub site with the progress. Okay, so the application is created. So we have it here, the container app demo container app. And so what you can see here now is that we have an application URL. So we can actually just click that one, and we just open the URL that accesses this container app. So this is, of course, a super simple web application, just showing me that welcome screen. So, but you can see how easy that was. And now I did it through the portal. I could also had been using the CLI that I showed you on the slide to do the same thing. Let me just zoom in on the URL here. So you can see now that I automatically got this URL. So traffic is now hitting my site. And you can see that the container app demo this is the name of my application. And then you have this thing here, which is actually the environment. So of course, this is now like a kind of randomly generated name for my environment. And of course, when this service is going on GA, you will be able to attach a custom domain, of course, to your app. So you don't need to use this, of course. But by default now, traffic is hitting my site, and I didn't really have to do anything about it. I didn't have to do the certificate management or anything, which is really nice. And we have some settings here. For example, we could attach secrets to our application. So things like connection strings or API keys or something like that could be added here and made available to my application. Again, we have the Ingress here, which I showed you before, which now routes traffic to my application. And we'll talk a little bit more about that in a second, because this can also do a little bit more advanced traffic routing between different versions of this application. So let me go back to the slide and let me talk a little bit more about in details about the different concepts in container apps. So we have this concept of an environment, and this is really the isolation boundary for your application. So inside that environment, you can now deploy one or more container applications. So in this case, we're creating something called the container app 1. And inside that you have you can have one or more containers running. And so here it says pod, and pod is a Kubernetes concept. This is in real life, that's where your container is running. This is not really visible when you're using container apps, but what actually happens when you deploy it, it will end up in a pod in a Kubernetes cluster somewhere. But actually, there's an additional concept here. Every time you deploy a new version of your container application, it creates what's called a revision. So the first version that you deploy will, could be like revision 1. And when you deploy a new version, it will actually create revision 2. And then it will kind of route the traffic to that revision, and it will eventually deactivate the first revision. And this is done automatically now. So this is not something that you need to handle, but this makes it now possible for you to do new deployments without causing any downtime, because the old revision is running up until the point where the new revision is running. And we can also do things like A/B testing or blue-green deployment, where we actually direct traffic between these two revisions. So this is actually a really nice part of the service that you don't need to handle that. You can just deploy new versions and the users won't get any downtime. Of course, now you can deploy multiple applications inside this environment, and these applications can of course talk to each other. And so what's common within this environment is that all of these applications will now run in the same virtual network. So either this will be a generated virtual network for you, or you can supply your own one. And this is what makes it possible for the applications to actually talk directly to each other without having to go through like the public internet, which is of course is very nice when you have internal APIs in your microservice. You don't want to expose them necessarily to the outside world. You just want to make it possible for other parts of the application to talk to those services. The other thing that is related to an environment is what's called a log analytics workspace. So this is how Azure Container Apps supplies the service of monitoring and tracing. So everything that your containers will output in forms of metrics and logs, it will automatically be sent into a log analytics workspace, from which then you can do queries and alerts and monitoring and so on. And I talked about these revisions and the term of traffic splitting. So this is an additional feature you get with this concept of revision. So what you can do now is that you can deploy a new version of your application, like revision 2, but instead of just sending all the traffic to that new revision, you can actually send part of the traffic to that new revision. So in this image, you can see that we're still sending 80% of the traffic to the old one, and then we're sending 20% of the traffic to the new one. And this allows us to do multiple things. It allows us, for example, to gradually deploy a new version into production. Just close that one. Sorry about that. You can also do things like blue-green deployment. We can do A/B testing. So in effect, we'll have multiple versions of the application running at the same time, and route parts of the traffic to either one of them. So again, this is not something that you need to implement yourself. This is just part of the service, and you can do a lot of things with it, which is really nice. So let me actually show you how that looks. So let's go back to the application that we just created. And you can see that we have a section over here called the revision management. And in this case, we have one revision. That's the one I just created. And you can see over here traffic. It says that 100% of the traffic is routed to this application. So if I would now deploy, for example, a new version of my site, maybe I have a pipeline somewhere that would deploy it. It will create a new revision. That's probably the most common way of creating a new revision when you deploy a new version. But other actions that would create a new revision is, for example, if you change some of the configurations around this revision. So let's click into this revision and see what it looks like. So again, you can see here that we have the URL. We have one replica, so we have one instance here. And we can see a little bit more information here. We can see more information about the container itself, the one we just deployed. We have the scale tab here. So it says how we actually configured scaling for the application. And we also have some information about Dapper, which I'll come back to. And I didn't enable Dapper on this one. So actually now what we can do now, we can edit this revision actually straight from the portal. And so, for example, what we could do now is by default, the scale settings will be set from like a minimum from 1 to up to 10. But I don't have a scale rule here. So this is actually how you would configure how your application will scale. So should it scale on like the number of HTTP requests? Should it scale based on a queue or something else? But just to show you now, well, actually I can change, for example, these settings here. If I, for example, change the min and max replica here, let's say I want to have 3 replicas with the option to scale up to 5 or 6, and let's create that one. So now it says deploying a new revision here of the app, because now I changed a part of it that actually causes it to create a new revision, in this case the scaling configuration. So that's another way of actually creating a new revision. And of course, this is something that you can do from the CLI or from the pipeline as well. And let's just wait a few seconds until that completes. So what actually happened now, it applies these scaling rules. And if we go back here and look at the overview now, and we can go back to the scale here, it actually says 0 here. So let's go back to the application here. And we should be able to see now that we have actually on the new one. So now we can see that we have a new revision here. So the old one is this one, and now it has a new one, and this one is what gets the 100% of the traffic. So the old one is still here, but it doesn't get any traffic, and it will eventually be inactivated by Azure Container Apps, and in the long run, it will be deleted completely. And if we go in here, we can now see that we have 3 replicas. So we basically, what we've done now is we have scaled it up to 3 instances, so it can now actually accept more traffic. And the built-in load balancer will now route the traffic to either one of these instances. So again, but the important concept here is the one around the revisions. So every time you deploy a new version or you change some of the configuration, you create a new revision, and you can also select how you want the traffic to be routed to it. So I talked about this one, and so let's talk about scaling. I showed you a little bit here, and this is under the hood is using an open source project called Kada, which has all of this implementation of, or the functionality around how you can scale your application. So either if you want to scale it on the number of HTTP requests or CPU memory or something event-driven like queues or storage or event hubs or Redis cache, anything that can trigger event, it's something that you can use as a scale trigger. And if you're not familiar with Kada, you can read all about it over at kada.ash. But again, this is an open source component for event-driven scaling in Kubernetes. So this has been around for quite a while, and you can use it in your Kubernetes clusters today. But the Azure team has now kind of embraced it and built it into the Azure Container App Service. So everything you can do in Kada, you can do it. You can use that here as well. And so this allows you to scale from all the way from 0 instances up to 1,000, or how much resources you're willing to allocate or pay for. And the scale to 0 one is actually quite interesting, and I will show you a demo of that soon, because there's many cases where you want to have something to be able to react to certain events, but it might be quite irregular how often it needs to run. And now with Azure Container Apps, since you're just paying for, if you're not having any instances of your container app, you don't have to pay for them. So it's really nice to be able to scale it down to 0 and have container apps actually scale it up for you as soon as you need to. The other kind of service or platform that is enabled through Azure Container Apps is Dapper, which is short for Distributed Application Runtime. This is another open source project which intends to make it a lot easier for you to build portable, event-driven, distributed applications, either in the cloud or in the edge. And you can read about this in dapper.io. And so Dapper consists of multiple building blocks. So it tries to codify like different best practices that you very much need to to handle if you start building a microservice type of architecture, because when you're building distributed applications, some of the things you need to handle. So you need to find ways of communicating between them using, for example, publish subscribe or direct service to service invocation. These are things that is not really tied into your particular application, like the domain you're using. These are things that is quite general, and it's something that tends to be implemented over and over again in multiple applications, and that's why it can make a lot of sense to kind of build this once into a block that you can use then. So there's more blocks here around, for example, state management, which allows you to very easily store state into different types of state stores. You can use this for secrets, to securely access secrets from an application. It has support for distributed tracings and a lot of other things. And the general idea here with Dapper is that you have multiple services in your application. And for example, if you want to communicate between these services, so you want to make an API call, you actually do that through what's called a Dapper sidecar. So this is something that comes with Dapper. So every time you deploy your application, you will also deploy a Dapper sidecar running next to your service. And Dapper will then handle all the communication with the other service. So it actually solves the problem of service discovery and adds things like tracing and log and metrics and secure communication. You get this kind of for free. So you don't need to build or think about that yourself. And in addition, Dapper then supports a lot of different the building blocks that I talked about. So for example, you can use the state stores and to load and save and query state. And then there's like multiple implementations of this. So for example, you can use Cosmos DB, Redis, Cassandra, and so on. And there's a long list over at you can check out at the Dapper IO site for the different types of implementations here. So it's kind of an abstraction here, which makes it easier for you if you're developing multiple different microservices. You don't have to kind of learn all of these technologies. You can just pick the store and use the Dapper abstractions here. So other building blocks, for example, is the publish subscribe. So again, you can use this for messaging to communicate between your services. And then you can use the implementation here could be, for example, Azure Service Bus or N Service Bus or RabbitMQ or Redis. This is something you can just pick. It doesn't really affect your code. This is more of a configuration that picks the service that you want to use. So there's multiple things of Dapper, and this is a session itself, so I just want to mention it because it's actually part of the container apps. And I will show you a quick demo of how it actually works, how you run this locally, and how it runs in Azure Container Apps. So if you go back to kind of the slide I showed you before, how it looks with the environment and the container apps, when you run this with Dapper enabled, again, Azure Container Apps will then automatically deploy this Dapper sidecar. And then you can just use Dapper to communicate, for example, with the other services or talk to the state store and so on. So what Azure Container Apps does for you is to deploy and configure Dapper for you, so you don't need to do that yourself, which is then really nice. So I want to show you a demo of some of the things that I talked about here. And the demo is available at GitHub. I will show you the link afterwards. And it just consists of 3 super simple applications or like services. So we have a web application that shows a list of orders. We have an API that can accept to create a new order. And then we have an order processing kind of background job that will use or kind of read the orders that has been sent to an Azure Service Bus. So in this case, we're using Azure Service Bus as the publish subscribe service. So basically, the API will publish an order created event on the service bus, and the order processing will consume those messages. And then eventually it will store its state into a Cosmos database. And to show this, the scaling part of it, we're going to scale the order processing application here. So if we start sending a lot of orders on that service bus. We want to actually scale the order processing here to multiple instances to be able to consume those messages faster. If we only have one instance, that instance will just read one message at a time. That doesn't really scale. So this is a very common pattern. It's called a competing consumer, where it just can scale out to process those messages faster. So let me show you this. And again, I will show you the link to the source code later on. And so this is the applications. We have the three different parts here. We have the web application, we have the API, and we have the order processor. So that's the background job. And I'm using Dapper now. So this means I'm using the Dapper to actually communicate between the services, to send messages, and to store state. Just to show you a quick example of what this looks like, without going into much details, is that for example, when the web application called the API, I'm using the Dapper SDK here. And I can just say that I want to call a method on the order API component, and that method is called order, and it's a get. And so what's nice here is now I don't need to, so Dapper solves also this concept of service discovery. I don't need to know exactly where that service is running. I just know that it's running on the same network, and Dapper will solve the communication for me. So this works when I run it locally, and it will also work when I run it in Azure Container Apps or Kubernetes or something else. So that's really nice. Again, if we go into the API, it will receive this this order that's been created, and it will then send an event to a service bus. And this is just one line of code. I use the publish event async, and I will use a binding. So basically, it will wire up everything for the Azure Service Bus for me. I don't need to code anything around it. And the magic here is actually located in a few YAML files. So in this case, I have a Dapper component, which actually then specifies the information how I can connect to that service bus, and a few different types of configuration that is relevant to the service bus. Same thing, you want to store some state in the Cosmos database. I have another component that gives the connection information. And by doing that, if we go all the way down to the order processor, which actually saves the order, it just uses a save state here to save the order. That's all I need to do. So the code is now extremely simple, and then I can actually now pick what type of states do I want to use, because it's not tied to the code. If I just change this configuration in my YAML files, I could actually, for example, use a Redis store instead, or something else, without actually changing any of the code. So I can actually now run this locally, and it will just spin up all these different parts of the application, and it will then consume or communicate through Dapper. And so this is a really nice developing experience. It actually runs all of these applications, and I can talk between the different services in exactly the same way as I will do when I run this in production. So now it just shows me all of the existing orders, and it reads them from a Cosmos database. So this is nice, and this is how I would run it locally. But we're focusing now on Azure Container Apps. So I have deployed this to Container Apps, and if you want to peek more into the source code, you will actually see that I do this through a Bicep, which is the new kind of version of Azure ARM templates. And if we just look at one of them, for example, the web application, we can see this is the Bicep file that deploys the container application. And so you can see it deploys a container app, which is called Order Web. We have the thing that I showed in the portal before. We're configuring Ingress. We have some secrets. I specify where the container image is located. I enable things like Dapper. I have the scale settings and so on. And you can look at the details on the GitHub repo later on. And then I have a pipeline that actually deploys this for me. But let's head over to the portal, and I will go to the resource group where I have deployed this. It's in the container app one. So here now you can see again I have the container app environment, and I have the log analytics workspace, which we'll look at in a few minutes. And then I have the 3 different components here. So we have the order web, the order API, and the order processor. And again, we can open up the order web component here, and again we can see the URL here. And it should now show exactly the same application, but it's now running in the cloud in an Azure Container App. So this is nice. It's now running, and let's now, and again, now these components talk to each other through Dapper, the Dapper sidecar. And even though you can't really see that, it really solves the problem now of service discovery. I didn't have to change anything to be able to talk between this, because now, since they're running in the same environment, on the same network, they can now talk to each other, and they can talk internally to each other. So I don't, for example, I don't need to expose the API if I don't want to. I could have it completely internal, which is really nice. And let's take a look at the order processor here. And so what's interesting about this one, if we go to the revision management, is that I have set the scaling on this one to scale on the number of messages in the message queue. And actually, let's just quickly go to that one just to show you the details here. So in this case, I have the scale section here. I say I want to go from 0 to 10 replicas. So a replica is an instance of this application. And then I have a scale rule where I say that I want to scale this application based on the service bus, on the queue length of the service bus. So basically here I'm saying that as soon as we have at least one message on that queue, I want you to scale up, and I want you to scale up to a maximum of 10 replicas here. So we can actually see that now that it says 0 replicas here. And so this is quite interesting now, because it means that this application is deployed, but there's no instances of it. So that means I don't pay anything for this application because it's not running. But it will run if I start to actually send some orders on that to that service bus. That's the idea, at least. So let me try this demo where I'm actually gonna send some orders to that service bus, or actually through through my API. So I have just a simple PowerShell script here that will just start sending some orders. And let's see if we can scale up this order processing here. Now we can check this in the portal, or I can use the CLI. So I can, for example, list the revisions for my order processor here. And now we can actually see already that it's scaled up to 1 replica. It was 0 just a few seconds ago, and now it has 1 replica. And if we wait a few seconds more, it's going to scale up even more. Now it has 4 replicas. So what actually happens now is it's scaling out my order processor application, so it can now consume messages from that queue faster and faster. And again, this was done under the hood by Kada. I didn't have to deploy Kada or anything. I just specified that scaling rule, and now it scales up for me. And it will, it continues to scale up until it reaches the maximum, and then when it has consumed all the messages, it will eventually go back to 0 instances, which again means that I don't actually have to pay for this application when it's not needed. So this is actually really nice. Let's take one more look and see if it actually scale up. Yep, now it's running up to 10 replicas, which means now that it actually should consume all of these messages quite fast. And then there is a kind of delay, and then it will go back to 0 instances. So that was a quick demo of how you can use Kada for scaling, and how Container Apps integrates with Dapper, so it kind of deploys Dapper for you. This is of course not something you have to use, but it does make it a lot very easy. It's a lot easier to kind of build and develop your microservices. And so again, this service is in preview, of course. So, but pricing is always interesting, but of course this is subject to change. So I've included just a screenshot from the pricing page from the Azure documentation, just to show you how Azure Container Apps is being billed. So you're getting billed on two different things. The first one is like the number of requests, and the other one is the resource consumption. So what you can see here is that you get for each container app, you get 2 million requests for free per month, and then after that you will pay 56 cents per million requests. And in addition to that, you will pay for the resources, which means that for the CPU and the memory that you're using. So basically, you're paying this amount for CPU and this amount for memory. And you can see that it's actually differing on active and idle usage price, which means that if you, for example, if you have a minimum number of instances that is running in idle mode, it will be charged at reduced rates when it isn't actually processing any requests. So then it gets very cheap. So, but the pricing in here is this is called like CPU seconds. So and you have a gigabyte seconds. So if you consume 1 gigabyte of memory for 1 second, you will pay for 1 gigabyte second, and each of those costs like $0.000004. Again, of course, this is subject to change over time, but this is the current information, and I think the model will stay the same, but of course, then the individual prices will change over time. But again, the basic idea is that you're paying for what you're using here, and that's a core thing. For example, if you compare this to Kubernetes, if you deploy a Kubernetes cluster, you have to pay for that cluster. Even though if you're not using it fully, all your nodes, you will still be paying for those nodes. So this is a much more attractive model. So that's actually what I wanted to show you. So this is a kind of quick introduction, and maybe later this spring we'll do more of a deep dive. But hopefully I showed you like the main concepts around Azure Container Apps, and I highly recommend you to look into this if you're interested in building like a multi-container application and run it with ease without learning all the details around Kubernetes. This is really a service for you, and it will of course keep evolving. It's not done yet. A lot of things are coming before it goes GA. So and I have the link here. Maybe we can add it to the chat. So this is where this is the source code that I just showed you. It's available on my GitHub account. Of course, you need to add your own keys and connection strings to actually make it work. But everything I showed you, including the deployment pipelines and the bicep files, are there, and how I use Dapper to integrate between it. So feel free to check it out. And again, if you're living in Sweden, you can head over to this URL, activesolution.se/stickers, and we'll send you some cool stickers. You can also scan this QR code. So we'd love to talk to you if you're interested in working with us at Active Solution. And I also just want to mention this is part of a series. This is the fifth part, the Azure Container Apps. And next week I'll be doing the last one, where I actually will delve into Kubernetes and Azure Kubernetes Service. So this will be the last part. And my colleagues have been delivering sessions all up until now. So all the previous ones are available on the Reactor YouTube channel. And then we also have the other track, the AI and machine learning track, which is also still running. So I think yesterday was the custom vision one, and next week Robert will do the last one around Azure machine learning. So a lot of great information here that's available for free. So please check it out. It's a great way to kind of get started and dipping your toes into all of these different areas, and kind of get a sense for what are your options and different ways of designing applications, running applications, and so on. So great. Let me see.
Thanks, Jacob. We do have a couple of questions, if you're okay to answer.
Yeah.
So there's a gentleman who says, why using the GUI, not Azure ARM or Azure Bicep to provision this infrastructure?
That's a good question. And generally, I don't use the UI to create anything. I just think that for demo purposes, it can be nice to kind of show you the UI because it's kind of shows you different options from drop downs and so on. So it's exactly just for demo purposes, I'd say. But also, I did show you like the CLI that I normally would use for example, the thing I did in the portal is done by using this one, or again, if you're using the bicep file, I would do it like this one. So again, the UI I think is nice for demo purposes.
Thank you. What is the difference between AKS and Azure App Container?
Azure Container Apps maybe was the question then, I would assume, which is the service I just talked about. And so the big difference is that the Container Apps is really something that is built on top of Kubernetes or AKS. So when I deploy a container app like this, it will actually run in a Kubernetes cluster somewhere, but I don't need to know anything about it. So I don't need to create the cluster. I don't need to know how to manage the cluster or how to operate it. I just kind of deploy something on top of it. And I think we'll see more and more of these type of services because Kubernetes is a great platform and it's really, really powerful. And it's portable, so you can run it anywhere, but it comes with a lot of complexity, and this is what this type of service tries to solve. Just make it a lot easier to deploy multi-container applications on top of Kubernetes.
Do we know how the cost compares to AKS if running same workload?
So the big difference in cost, again, is the fact that you don't need to pay for your application if it's not running, which in contrast in AKS, if you have a 3-node cluster, for example, you will always pay for those nodes, even if you're not really running anything inside it. How much you will actually pay for your application is, it's a little bit hard to say. You saw the numbers there. And of course, it can be hard sometimes to actually know what your application will actually cost. That's kind of the other side of the coin here, that you only pay for what you use, but you kind of have to figure out the actual cost here. So it really depends on the amount of resources and the amount of requests that your application will receive, to actually be able to say how much it will cost. But I'd say for many cases, you will be able to run this cheaper compared to a Kubernetes cluster. And if you have an existing application, I would probably deploy it and run some tests on it, maybe run some load tests or something like that to see, how much resources do we need, and then you can do your own calculation of how much you would actually have to pay for it.
I'm going to take one more question. Says, do you already know when ACA will be out of preview phase?
No, I don't, unfortunately. So I just know that it will be this year. I think it will be before summer, but there hasn't been any official dates announced yet, unfortunately. So I would guess before summer, but we'll see.
And then one last question. Can you run multiple different pods on the same app? And do you experience any significant cold starts?
Yes, you can definitely run multiple pods. And that's what you're actually doing when you deploy. Actually, we can do. When I deployed multiple applications like this, what actually happens is each of these applications, the web application, the API, and the processor will run in each pod. And the cold start is, I think, what I showed you with the scaling part when I scaled from 0 is that there is a delay there. And with CADA, you can configure these delays, like how often for example, should it poll the queue, for example. As of now, this configuration setting isn't exposed to Container Apps, so you can't configure them right now, but I know that they're working on that. So you can actually configure yourself, like, how much delay, how long do I want to wait before I scale up and before I scale down and so on, because that actually affects, the prices. But for like a regular application, like the one that I deployed in the beginning, you can see that it starts up really, really fast. So there's very little cold start delay there. And again, if you have applications that you don't want to have a delay when you're like a cold start delay, you always want to have like a minimum number of replicas running all the time. So you typically don't want to scale them to 0, because that will actually give you a cold start delay. So you probably want to have at least a number of replicas running to be able to respond fast. And again, what I talked about and showed you around the traffic splitting between different revisions, that's really nice, because that actually allows you to deploy a new revision. You could potentially actually hit some traffic to it, like to warm it up. And then when the traffic shifts, it's completely warmed up, and the end user won't experience a delay at all, which is really nice.
Great, thank you. I think we're out of time now, but thank you very much, Jakob, for the presentation. And obviously, we'll see you next week, same time, same day.
Yeah, thank you for joining and for asking some great questions. And hopefully, I'll see you next week.
Perfect. Thanks, everyone. See you next week.
Bye-bye.